Okay, just a minor note to everybody, and that is that it is a book test. So if you know the book, you look at your notes, your lecture notes, YouTube videos, you should be fine. You should be fine. Okay? So the last thing I want to look at is this. I have an electron configuration. Now remember, what are the valence shells of elements based upon? The subshells of what? What subshells? S and P, correct, S and P. So let's look at something called sodium. Okay, sodium looks like this. Okay, sodium has a filling of that. Yes, that's the electron configuration of sodium. Chlorine, I'm going to make it disjointed here.
Sorry, I just can't see from.
You what?
I can't see from that point of view.
Okay. Chlorine looks like this. Now, what's going to happen with chlorine and sodium is that this electron here is going to, this electron here is going to be transferred to here. Now, what determines whether or not that transfer takes place? The what?
Ionization energy.
No. It's in the chapter. This is called Ionic bonding, right? And what when you have this transfer, the transfer of an electron, you guys know enough about chemistry to have heard about ionic bonding, correct?
Right.
Ionic bonding is a transfer of an electron, correct?
Yeah.
In this case, from sodium to chlorine, correct? What is the determination as to whether or not it's going to be a transfer or a partial sharing of two electrons going to be based upon?
It's positive.
Electronegativity.
Electronegativity. There you go. The electronegativity. Yes? There is a certain, I have the anion, which is negative charge. I have the cation, which is positively charged. Correct? Let's make that on the other way around. I have the cation,
Positive.
positively charged. I have the anion, negatively charged. Yes? And what determines whether or not it's going to be an ionic bond or not, but a difference in electronegativity. So it'll be the cation electronegativity minus the anion electron negativity, which will result in a value. We'll call it difference in electronegativity. Correct? Now, that difference will determine whether or not a bond is going to be ionic or covalent. You actually have to look in the book, and it'll be the next chapter, and that book will tell you a above and below value. If it's large enough, for instance, cesium is approximately 0.7. It is approximately 0.7. It is what did I say? Cesium, right? Did I say cesium?
You said cesium.
I said cesium. It's approximately 0.7, 0.6, 0.7, okay. Fluorine is 4. So let's say that cesium is 0.7. What would the difference between chlorine and cesium be? Guys, that's a question. 4 minus 0.7 is 3.3. Are you guys here? Yeah. So 3.3 is a difference. We know that 3.3 is a large enough difference to be ionic. What's the electronegativity? It's right in your book. It's right in the end of the chapter. What is the electronegativity of sodium, and what is the electronegativity of chlorine?
Sodium is 0.9.
What is it?
Sodium is 0.9 and chlorine is
0.9 is sodium
and 3.0.
and 3.0. So the difference would be 2.1. Is that correct? We know that sodium chloride is definitely ionic. So if it's 2.1 or greater, it will be an ionic bond. Now, if you have a bond that has a very low electronegativity,
It's covalent.
for instance, let's look at that's carbon dioxide. Yes? Yes? Okay. So I see that there's bonding here. Let's not use that one. Let's use this one. Hydrogen and oxygen. Those are easily covalent bonds. That's a covalent compound, correct?
Yes.
Yes? Okay. What is the ionization energy of oxygen?
It's 3.5.
I'm sorry, the electronegativity.
Yeah.
Oxygen,
Two.
En is 2,
3.5.
3.5, and hydrogen,
2.1.
It's not one.
what's the difference?
Would be 1.4.
1.4. So 1.4, a difference in electronegativity will be 1.4. Is 1.4 a covalent or ionic?
Covalent.
It's covalent. So I say that this is going to be a sharing. So here is sodium. I'm sorry, here's hydrogen, looks like this, correct? Yes, that's hydrogen. And oxygen looks like this. Let me move it over a little bit.
Sir,
Okay?
hydrogen doesn't look like this.
How would you know if it's a
Hydrogen
covalent?
doesn't.
Hydrogen has one electron.
Oh, yeah, that's an S. I thought it's B. Sorry.
That's okay. Yes?
How would you know if it's a covalent bond?
Well, that's what we're trying to determine. Fabiana says, how would you know it's a covalent bond? That's one of the points I'm trying to make. Okay?
Less than 2.
So this is oxygen. Right? Is that oxygen? Correct. Now let's put another, we're going to put another bond there. So do you see that I'm going to get this kind of situation here. Let me back this up a little bit. Let me draw it like this. Okay? So what's going to happen is this is going to go with this, and this is going to go with this. Okay? They're going to share. Yes? Now, that's bonding. That's the next chapter. And Fabiana asks, isn't this an interesting question? How do you know if a bond is covalent? Well, the point I'm trying to get to is you can determine relative states of a bond, it's covalent or ionic, based upon your experience. For instance, you know that sodium is ionic, correct? You know that water is covalent, correct? We know that water is 1.4. So anything 1.4 or less in terms of a difference is going to be covalent, right? Anything greater than, what was sodium chloride?
2 or so.
What was it? What was the difference between chlorine, which is 3, and sodium, which was 0.7?
It's 0.4.
What is it?
Sodium is 0.9.
2.1
All right, 2.1-ish. All right, if they made a mistake, okay, guys. But the point is that there are ranges that you can determine whether or not something is covalent or ionic. Yes? So, let me ask you a question. Is it important to read the section and understand the section in Chapter 6 about electronegativity
Yes.
relative to understanding bonding, which is in Chapter 7? So what should you understand for Tuesday's test?
Everything.
Everything, including electronegativity, correct?
Yes.
Electronegativity is an attraction for bonded electrons, correct?
Yes.
Go have some lunch.